Hello, everyone. Good afternoon. Dear authors and invited guests, welcome to the technical session 7B. Myself, Aarti Mohan, and I would be moderating this session. On behalf of Global Knowledge Research Foundation, it's my great pleasure to welcome you all to the 9th International Congress on Information and Communication Technology, ICICT 2024, London, UK. The 9th edition of the conference is being organized in a hybrid mode, and the virtual event is being held through Zoom today, that is 22nd February 2024. I hope you all will be enjoying this knowledgeable and interactive session through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentation and 2 minutes for the question and answer session round. On 10 minutes, I'll raise a gentle reminder. There's another request to all the participants to stay connected with us till the closing remarks. If you have any sort of query or any update, you can write it to me in the chat box. Just before we get started with the presentations, I would like you to introduce to the session chairs who would be chairing this session. Dr. Shafi Pathan. Dr. Shafi Pathan is currently working as a professor in Department of Computer Science and Engineering, MIT SOE, MIT ADT University, India. He has an experience of 23 years, worked as a lecturer and associate professor in Srimati Kashibai College of Engineering, Pune. He is working as a technical director for Machine Maths Technologies, Pune, handling project management, deployment of project and resource management. It's an immense pleasure to welcome you to this conference, sir.
Thank you, Aarti.
I would like to invite Dr. Montador Farron. He's an associate professor in Kristianstad University, Sweden. His research background is in computer science, psychology, and pedagogy, which resulted in a teaching degree for upper secondary school. After graduating, he became interested in the intersection between information, technology, and psychology, which led him to study a master's degree in psychology at the University of Wisconsin-La Crosse and the University of North Carolina, Greensboro. After that, he continued with a PhD education in information society at Stockholm University, where he examined the interplay between these two areas in the context of democratic engagement. It's my immense pleasure to have you on board with us, sir.
Thank you so much. It's a pleasure to be here.
Shafi sir and Montador sir, if you have any, introduction to be done in addition to this, you may please proceed with the same.
From my end, Aarti, you had a nice introduction. Radhavan, thank you very much for so nice introduction. Nothing to say from my end.
I completely agree with Shafi as well. You made a really good presentation. I could just add that another direction in my current research is in the intersection between artificial intelligence and education.
Oh, that's great, sir. Thank you.
Thank you.
Okay, moving on to our presentations. Now I would like to have Yeli to present her paper on bilinear polling of transformer embeddings for blind image quality assessment. Dear presenter, could you please proceed with your presentation?
So can I share my window now?
Yeah, sure, you can. Please.
Okay, could you let me know everyone can see the screen I shared?
Yes, we can see the screen.
Okay,
Yes.
so my voice also clear. Okay, good. So I get started. So yeah, good afternoon, good evening, everyone. I'm presenting from Singapore, so my time is 10 p.m. Today, the paper I'm presenting, the topic is on bilinear pooling of transformer embeddings for a blind image quality assessment. So let's get started with. Okay, first, the background. So image quality assessment is a research topic used to be studied in full reference or no reference, i.e. blind setting, where a small amount of poor quality images were generated by a software method. For example, adding a Gaussian blur or Gaussian noise. However, in our current era, which there are, say, billions or trillions of photos on internet, which captured in the various different environments. So all these images may have authentic distortions, which are much more complex than the classical software-generated synthetic distortions. I just have example below, for example, an authentic distorted image, which is in the night with some highlights. So in short, BIQA, which is blind image quality assessment, well, becomes very useful in such a new context. However, the performance in the literature, which are the methods proposed, are still far from human-like performance by the accuracy for predicting the quality. So it remains a challenging research problem. So based on that, this paper investigates the potential of the latest deep learning models, which basically are the vision transformer. Those pre-trained vision transformer, use them as the potential for extract good quality aware features. Based on that, we propose a method that leverages multi-level transformer embeddings output and used by linear feature pooling method to engineer better feature to assess authentic distortions. Furthermore, to further enhance the quality prediction performance in the model training, non-monotonic error regularization is also introduced. So, of course, before start introduce the proposed method, we here go through a very brief on the pre-generation, not a very early generation, the latest work which related to use the deep learning-based method as backbone, especially the CNN, which stands for Convolutional Neural Network, as backbone for quality-aware features. In the literature, generally, there are two approach. One approach is basically just took the pre-trained image net models, CNN backbones, to extract multi-level of blocks. For example, in this paper, this actually 2022 paper, they used 3 convolutional block output from a pre-generated ResNet, and they used that to design quite complicated, in this case, is a complex convolutional neural network to further process the feature and finally predict the score. That's one way, which is not touch the pre-trained model. Another main approach is to fine-tuning the pre-trained CNN. In this case, this is a 2020 work, which you can see that when we fine-tuning, so after the fine-tune, the downstream structure of the network for prediction is much simpler in this case. But by leveraging fine-tuning means we change the weights in the pre-trained model. So as we know that after the CNN, the latest generation, which works the best in the understanding image, is the vision transformer. So here is a work from a 2020 work, which is in relatively enhanced structure of the vision transformer. So in generally, these pre-trained vision transformer, they do a fixed task, which is predict the class, which are the objects in the image. So basically, this is general architecture, that all the images coming in, we would say grid into patches, in this case, several patches. Then each patch will extract the information in it, and then patch it aligned together with the position, patch 1, 2, 3, 4. So forming a input embedding. Then there are multiple layers of the transformer encoder to further process the input embedding vectors. Eventually, they have a multi-layer normally is a 4 connected neural layer to generate the output of the class. So on the right hand are the illustration of some detailed information of the transformer, one particular transformer encoder. We will not go dive into that because of time, and in this work, nothing is touched. We use a pre-trained transformer without any extra architecture change to the existing visual VIT. So here is an outline of the framework of the proposed method. On the right hand, we can see that the image utilize the existing VIT approach to generate the image embedding. Then the transformer block, for multiple transformer block, we extract its output and design a BPTIQ network to to dimension reduction of the original vector output, and finally generate a prediction real number, which is the quality number. So on the left hand are the formula for the quality aware feature, which basically is a formula to illustrate the picture work. So moving on to time. So yeah, the previous slides explained how the feature is constructed. On this slide, it's outlined the quality prediction method, which is a very simple linear layer, which is the quality feature, which is constructed from the previous page, then predict a mean opinion score, which is most value. That's which will compare to the real value in the to the human labeled most value and the evaluated result. In the IOQA literature, the metrics to compare the model performance mostly are the Pearson linear correlation and the monotonic, which is using the spear rank correlation coefficient equation. So to leverage the method to evaluate the model, so we also introduced on top of the conventional the absolute error, we introduce a non-monotonic error. So by non-monotonic error, which basically is that for a batch of n, say, samples in the training batch, so we sort out the predicted score and also the real score, and we penalize the prediction if it is out of order. So yeah, that's the extra regularizer. So there's a hyperparameter beta to need to be find optimal values. So let's go on to the next slides. So yeah, for the detail of the model structure, here is a layer detail layer. We're not going to go to detail. So the input are the last 6 encoder layer output from a pre-trained VIT B16 by 16 means 16 by 16 crops of the patch. So on the right hand are some of the hyperparameter for training the model. So let's go to evaluation. So yeah, we evaluate the method on the use the 4 popular authentic distortion data set to evaluate. On the right hand, we can see the size of each of the data set. On the left hand is the distribution of the score. So we can see that the PAQ to PIQ data set, the score is quite skewed to very high, relatively good quality. On the leftmost is very poor quality. So on the top, we give some, say, visual understanding regarding the quality. So for example, the first one is quality is 10 out of 100, which is relatively poor. The right hand is 98, which is the relatively close to perfect. So next, let's go through check the performance results. So on these slides, the scatter plot of the performance of the proposed method over the 4 data set. The blue are the training, the training prediction, the training sample prediction, quality of training sample. The red dot are the predict MOS score of the test sample. So you can see that they are quite aligned well. And top are the values. Moving on. So yeah, because we want to find out how the feature we proposed and the extra regularizer training method we proposed, the effect of each of the elements. So here is ablation study. So we can quickly go through it. We can see with the baseline is the baseline. The baseline is referred to the feature we use only the last encoder block output from the same pre-trained BIT model. So we can compare, we can see the column, which is highlighted, the column here, compared to the baseline, the feature we proposed has clear, say, help to improve the prediction accuracy. For the column here, the hours without error, which means at the regularizer. So we can see there are slightly a little help to majority of to 2 of the 4 data set. For the other 2, there's a little, say, negative result. That's the overall result. So let's moving on. So of course, we need to compare with the leading or state-of-art method, which based on mostly all of them based on CNN backbone. So we can see clearly our proposed method have say quite some advantage regarding performance. If we have design the prediction metrics as PLCC plus SLRCC, then our model outperform all the other 9 methods over 3 out of 4 data set in comparison. Of course, also whether the model trained on one data set can generalize well to predict in other data sets. So here is a cross-database performance comparison. So which basically here we reuse the model trained on each single data set and test on other data set, which is entire data set. So the bold indicate the best of the performance. We can see that our method exhibits relatively much more robust generalization ability compared to the other methods. Okay, so yeah, here's the end of my presentation. Next is the question and answer.
Monter,
Yes, I have a question. What can you say about the, like, can you give an example of the practical applicability of the results? In which context can we actually use them in practice?
Okay, so one example is that, as we know that, so all of these say, right now we have say all these applications, which they call AI application, which is a vision application. They can predict this, predict that, right? So as the literature is shown clearly that when the image quality is very poor, so the prediction result will be very likely to be say not correct. So one application is that because we use pre-trained model, right? So we do not change the structure so that it can be as a auxiliary, say, model, which is a small model auxiliary method to estimate the input say the input image or video, whether their quality is too poor. If it's too poor, then we may want to just say ignore the prediction because it's likely wrong, right? So which is related to, for example, the related field of study is before this IQA error is that now is the out of distribution detection, which basically very poor image quality image is kind of out of distribution in a way regarding signal quality.
Okay, thank you.
Thanks.
Hi, Eli.
Hi. Hello.
Hello. The question from my end is that,
Mm.
first of all, it is a good presentation. You have done very nice presentation. The best part is that you have compared the proposed technique with the existing techniques, and that is demonstrated too. That is good part. Now, my question is of this slide only, slide number 5. If you can see the operation here, function f of x, you are taking b, and again it is a function of b, again it is a function of b. But if you see the images, these images are converted into the array of images. So at the end, logic say that it should be concatenated rather than taking function within the function within the function. It may be like a recurring function like this. So what is your justification for the same? Have you got my question, Eli?
Okay, your question is around the expression of this formula y, b, and the b, and the b, right?
One function is taking input from other function rather than logic say that it is an array of images. So it should be concatenated, addition, multiplication. It may be like that. But here one function is providing input to the other function. Why it is so?
Okay, so let me go to the next slides to use the model structure to explain, see whether it can actually understand better. So the formula you raised the question is basically implemented in here, this whole block. So the x is the x are the this whole matrix, which is at 6 by 197, 384, which basically is the dimension from one of the encoder output. The n is the batch number. 6 is because we use the 6 block of output. So these are the x. Because we do recursive, so do recursive by say bilinear operation. So that's why I have this recursive x. So I think in here the slides I should make it more clear. The x1 minus 2 are dimension reduced already features. So here the x is okay. Sorry, let me use the so the x. This output should be the output here already. It's not from here. So this could be the confusion maybe. Did I explain? Help? My explain?
No.
Help? Yeah.
Yes. Okay, fine. It's good.
Thank you.
It is all from my end. Thank you, Eli. And thank you.
Thank you.
Thank you. Thank you so much for your wonderful presentation. Moving on to the next presentation, I would like to invite Buzrat Jahan to present her paper on detection of cyberbullying text in Bangla using n-gram analysis and machine learning approaches. Dear presenter, could you please proceed with your presentation? Okay, moving on to the next presentation, I would like to invite Alia Arif to present his paper on e-voting and e-recapitulation of system using smart card and smart contracts on the Ethereum blockchain. Dear presenter, could you please proceed with your presentation?
Okay, thank you very much. So, hello everyone. So I will share my presentation first. So, can you see the slide already?
Yes, we can.
Yes, Brahman.
Okay, thank you very much. Wait. We are. Okay. So, hello everyone. My name is Farman Soekarno. I am one of the presenter for the paper title e-voting and e-recapitulation system using smart card and smart contracts on the Ethereum blockchain. So the use case for the paper actually what happened in my country, Indonesia. So this is a bit about the research background. We need to see that the election should be followed the rules, but also need to consider what the challenge in the traditional voting we have been used in our country actually. Due to the traditional approach, we have fraud risks in every elections and requires the protection of the voter data. So in addition, we also need to look at the manual procedure, also the challenge in the accessibility, and also the financial burdens for the election process. And last, we need to see the vulnerabilities in the two things. First is the voting itself, the process of the voting, and then also the recapitulation, how we can recap the result of the election from the uh, lowest part of the region up to the national level, and see how the centralized oversights has the vulnerability. Now we come up with the two approaches for the background that we mentioned. First is how can we use the smart card actually to hinder the fraud in the identity of the voters, and then we use the properties of the blockchain to reject all kind of fraud in the recapitulation process. And then this is the design of the system that we propose. We propose the secure voter registration through blockchain. So all genuine voter should be put in the blockchains to avoid the modification of the footer, for example. And then we also need to protect the authentication of the voting by using the smart card. Actually, every person in the country has the smart card already actually as their identity. We also need to consider that the smart card and also the smart card reader follow the ISO standard to maintain the compatibility with the regulation. Then in the design, we try to look at how that the system can be efficient to deploy, and then transparent for recording, so which is provided by the blockchain. And again, this is the also the most vital is how to protect the recapitulation process. Again, from the the lowest part of the lowest level of the voting process up to the national level. So we need to maintain that the result of the voting has to be exact when the result is coming up to the highest level of the process, which is in the national level. it means that the recapitalization process has to be tamper-proof. No one can modify the result of the voting. So we can achieve these properties by using the smart card putting in the blockchain. And then so this is the flowchart design. Okay, from the start from the login process, yeah, up to how the voting is recorded in the database. So this is all done in the sequence of the process for the electronic voting system using smart card. We can see that in the first stage we try to protect the identity of the voter, for example, by having strong authentications using the smart card to prove that the voter is the genuine one. And then we try to see how can the voter do the voting process. We need to check the identity to the database, for example, and then how the voter can vote the candidate, and then store the transactions in the blockchains in order to avoid like modification and so on. We also look at the threat modeling and then the testing scenario as well. So in the left side, we show the fake identity threat modeling. Yeah, we have users and then smart card and then smart card read scanner. So what we need to see is how the interaction between user and the smart card and the smart card scanner is protected by the necessary security mechanism. Now we fulfill the requirement by following the international standard, which is ISO 7816, and then also the same standard applied to the smart card scanner. The right side, we can see the how the poor audited trail can treat the model. We can see that the role of the blockchain can protect the request and response from the users to the application of the voting system. So this is the implementation. Actually, in the left side is the blockchain implementation. We have the process, for example, to import the smart card to the blockchain. So the logic of the voting process is actually translated into the smart card logic, and then we follow to the access to the blockchain by using MetaMask. Last the transaction actually transferred to the smart contract, and then on the right side we show the transaction process in the smart card point of view, from the smart card to the smart card reader, and then the interaction of the servers. We can see that the necessary communication process is also protected by the encryption, for example, to make sure the confidentiality information is protected. In addition to that is we also applied the authentication process to make sure that the voter is the genuine one. So this is the what is it, the user interface, the sample of the user interface from the vote input, for example. So the left side is for the voter. The voter, for example, choose the candidate numbers and then followed by the NIK. NIK is actually our identity, our national identity. So this is unique for every person. And then on the right side is the user interface for the vote data. We see the chosen candidate number is protected. It means that the confidentiality of the chosen candidate is can only known by the voter itself.
So sorry to interrupt.
Yes.
You're left with 2 more minutes.
Okay.
Could you please conclude your
Yeah,
response?
so this is the security analysis. This is the role of the smart card in the robust authentication. Smart card is for the authentication, and then the role of the blockchain is to provide the transparent and tamper-resistant voter registration. So this is what we have now in the what is it, right side of the security analysis. Transparency is provided by blockchain recording, and then also the smart card for auditable and tamper-proof transaction. So yeah, this is the last slide. We have shown that the proposed paper has the holistic solution actually by having integration of the smart card and the smart contract. And then we also have shown the enhanced security, trust, and transparency in electoral system. Hopefully, it can be considered by the government to be implemented. So thank you for the time. That's the presentation. Thank you very much.
Thank you. Thank you. Thank you so much for your presentation. Sir, any questions?
Yeah,
I just have,
yes, sir.
yeah, go ahead.
Acha, thank you, sir. Dear Praman,
Yes.
you said that you are you have implemented using blockchain,
Yes.
isn't it? Which technology you use for the implementation of this project?
So the blockchain technology that we use in the research project is the Ethereum one.
Acha, it's a real one.
Yeah.
You use. Fine. By
Okay.
by default, integrity and authentications are done using blockchain only, isn't it?
Yeah. Blockchain, the authentication using the smart card technology.
Now, that is my question. Now,
Yeah.
if it is done by blockchain only, why you are using smart card once again?
Okay, so the smart card is basically to is used to provide the security of the voter. You know what happened in the election process is the what is it? Not genuine person try to vote.
Yes.
We then protect that only the genuine one can do the voting system by providing the smart card.
How
So
it is done, how it is done in your country right now?
yeah, actually everyone now has the smart card based identity. So we exploit the technology of our national identity smart card, not only just for the identity, but also can be used for the election process. Yeah.
Is it a ballot paper election there? Ballot paper election? You are using ballot paper for voting?
I beg your pardon?
Are you using ballot paper?
Ballot token?
Papers?
Yeah. At the moment, still paper, but what we propose is we don't need the paperwork. So what we can propose is the digital approach by having the smart card and technology actually that we have, but it's not utilized for the additional activities.
What is your comment on scalability of this system? Scalability?
Yeah. The scalability is one issue in blockchain, Dr. Safi. So by using Ethereum, actually, we try to see the Ethereum version 2, where the scalability is uh, much better than the version 1, Dr. Safi, because due to the energy consumption, for example, and then the algorithm of the consensus. So we are moving forward to the Ethereum version 2, Dr. Safi.
Okay, Parman, it is all from my end.
Thank you very much.
I just have a quick question, Naparman. Thank you so much for the presentation. Very good presentation, very informative. I'm just wondering, do you see any challenges with the system of implementing blockchain for people who are seniors, who do not have a lot of experience with digital systems when it comes to e-voting? Have you considered the senior group?
Yeah. Actually, the senior citizens has a quite high percentage in my country. So the system actually is designed to be also user friendly for those senior citizens. We designs the as simple as possible the system so that everyone, including the senior citizen, can use the our proposed voting system.
And what about those seniors who do not want to use it? Do they have any other options, or do everyone have to use it?
Okay, so what happened is we have challenges in the fake voter, yeah, in the election. So by having this, we encourage all voters to use this system. Yeah, that's why the proposed paper is not only consider about the technology, but also the regulations. Although this is part of the government, how we can move forward so that we have more credible election system.
Thank you so much.
Thank you.
Thank you. Thank you so much for your presentation. Thank you, sir, for your questions.
Okay.
Moving on to the next presentation, I would like to invite Wo Hong to present his paper on facial expression recognition, a light deep learning based approach. Dear presenter, could you please start with your presentation?
My name is Võ Hoàng Trương, and I have just finished my master degree at National Taiwan University of Science and Technology, and I will present to you my paper, which is Facial Expression Recognition, a light deep learning-based approach. In the contents of this presentation, we will go through 4 main parts: introduction, method, experimental results, evaluation, and discussion. Now for the introduction, facial expression is very critical for the development of machines or the robot cognitive system. And this system focus on utilizing the facial muscle movement to estimate the expression label in a picture or a video. And this kind of system is, it has many practical applications in interactive between human and robots, or medical treatment, and maybe human computer interface system. Well, normally the system that I use for this type of work would be the categorical model, which means that we will have many labels for the facial expressions, such as neutral, sad, angry, happy, etc. The features that usually we work with should be the handcrafted features. And these features, in many cases before, it has a lot of issues when it comes to the facial expression recognition. But firstly, for many people, we can have different ages, genders, or ethnic origins. So in order to design the handcrafted features from all of the people in many backgrounds, it is very nearly impossible for us to include all of these handcrafted features. In addition to that, because the input of the system is pictures or videos that are recorded from many types of cameras, there are a lot of variations in a posture, lighting, or some obstructions. And lastly, if we are not careful with the handcrafted features, we may have some subject identification bias, which means that we focus on some specific race or gender. So the model would be biased and perform not well for some cases. For some related works, many of the works before using the hybrid facial expression recognition, like they can have the combined with the features that are designed by human, like the handcrafted feature, and combine them with the machine learning method, or they move directly to the fully connected or convolutional neural network for this type of task. And normally these work with the convolutional neural network. These networks are very heavy and they will occupy a lot of computation requirement. Therefore, these models are not very friendly for the edge devices. So in our work, we would like to create a model that can have a decent performance, and it can be light enough for applying into the edge devices. So moving forward to the method, we firstly will talk about the pre-processing. Well, firstly, in order to recognize the facial expression, we must be able to capture the face only. Like within an input image, the model needs to be able to get and extract the region of interest, which is the face only. And in order to do this, we apply the Viola-Jones object detection framework using the HAAR features for facial extraction. The main reason for us to choose this framework is that it is very lightweight and the performance is very suitable for real-time detection. And for the model, we are inspired by the exception network concept. For normally, if we use a normal convolution layer, the number of the convolution filter, when increasing in channel, the number of the parameter will increase also. But if we use a depth-wise separable convolutions like the exception network, we will only use one filter for performing this depth-wise separable convolution. So therefore, we can save up a lot of parameters during constructing the network. And here is the architecture of our network shown in the table. You can see that this architecture is quite lightweight, and the input image is only 46 by 46. And the output would be the fully connected layers of 7, which is the 7 classes. And here is a representation of our network shown in a block diagram. And you can see that there would be 4 consecutive exception blocks. And we also, the normal exception block will not have the skip connection like the ResNet. So we want to combine the ResNet concept and the exception net to have a better way of learning the features. So that's why we have the exception ResNet layers like this one. And for the training parameters, the backside is 32, number of epochs 100. We use the optimizer Adam, learning rate of 0.001. We also perform some data augmentation like image rotation, shifting, and horizontal flip. And the loss is a categorical cross entropy loss. So here is how we design our facial expression recognition system. This framework should be real-time, and with the input is a frame from the video stream. We firstly use the facial detection Viola Jones framework to capture the face and then put the facial image region into the line exception net, and the exception net will will have the output of the predictions, and we will choose the label with the highest possibility. And the data set that we utilize for training would be the FER 2013 dataset. And this dataset is performed by Google, and it has a standardized 48 by 48 format with more than 28,000 job training photos, 3,500 validation, and 3,500 for testing. And here are some experimental results and evaluation. Firstly, about the evaluation matrix, we use the many evaluation metrics for it, and we use the accuracy, precision, misclassification, recall, or F1 score. For the result of the facial expression, here are some qualitative results first, and you can see that with the image input and applying with the images that is taken from real life, not from the FER 2013 dataset, and it works pretty well with our real life images. Here is also a video that we perform on an edge device and using only the CPU, and you can see that the response from the system is quite fast, and it is show that this framework can be applied on edge device. And here is the confusion matrix for testing on the dataset FER 2013. And you can see that the model performs very well with the happy class, but for the scare class, it seems that the scare class is usually be mistaken with the angry, and also with the sad. So here is the table that we calculate all of the metrics with the accuracy, misclassification, precision, recall, and F1 score. And you can see that the happy is the highest score. Here are some misclassification cases, and you can see that to the left side, it is angry, but the model misclassifies as neutral, or to the right is the disgust, but it was misclassified as sad. We also compare our model with some other baseline, and these baseline are very well-known models, and even they have a very high accuracy. Their number of parameters is very big, so that it is very hard for normal edge device to operate on these models, and therefore this table which serves like a showing of the trade-off between the computation requirement and accuracy. When the model decrease in the size, then the accuracy will have to be sacrificed so that it can fit in the edge device. So overall, the results showing that the system can perform smoothly on the edge device, and also it can having the performance of facial expression recognition. And for about the discussion, the proposal of the new model will it can be suitable for applying into some cases requiring a balance between the accuracy and the hardware resources. And also, if we would like to have a higher accuracy with the model, then maybe we can have a improvement about the feature extractor, and also these features should be higher quality, maybe increasing in the size of the input, or maybe using some techniques for extracting the features. And this model is recommended for some applications with the medium correctness requirement, or some limitations with the hardware resources. Here are some references that I used before in my presentation, and thank you for listening.
Yes. Oh, first of all, with the permission from chairman, I want to go for asking the question. Is it okay?
Okay.
Acha. I'm audible clearly?
Yes, sir, you're audible.
Acha. Fine. So I was very happy to see your own images you are using for the classifying, and I was very happy to see the different expressions which you have generated and classified. That was good part of it.
Oh, thank you.
Fine. Now you are using machine learning model. Can you tell me which model you are using? And I was not able to see that model was compared with the existing models which are available in the market.
Okay, so the model that I have been using is it was modified because this model we call it the line exception network, and it uses the concept of the exception net using the convolution, but it uses the channel-wise convolution so that it can save up some computation. And also in the exception network, there was no skip connection. And we want to apply the skip connection from the RESTnet. So we combine them together to have our own block of the exception block. And this we call the residual exception block. And there will be 4 block of this residual exception together in order to get the features from the image. And after having the features, we use the global average pooling. So normally we have a flattened technique, but with the flattened technique, it will have many parameters, and these parameters will also make the model become heavier. So using the global average pooling will also decrease the number of parameters of the model. And then after we have the features from the global average pooling, we can have the fully connected layer to have the output of the classes.
Okay, we may conclude here. No?
Okay.
Yeah, it is all from my end.
Okay, and about the models that we compare to, we can see that there are very well-known models, right? With the VGG, the ResNet, the DenseNet, and these models are actually very good about the accuracy. But if we take a look at their parameters, it is very big comparing to our model. So our model, even though they are having not a quite good accuracy compared to the other well-known model, but in terms of the size and the feasibility to apply into the edge device, it is more suitable compared to all of the other baseline models.
Okay, Chong, we'll stop here. Over to Manthar.
I don't have any question. Just want to thank you for a great presentation.
Okay, thank you very much.
Thank you.
Thank
and
you.
also-
Thank
you,
you.
Professor.
Thank you for your wonderful presentation. Thank you, sir, for your questions, valuable questions. Moving on to the next presentation, I would like to invite Kanan to present his paper on fuzzy logic-based metric for machine translation evaluation. Dear presenter, could you please proceed with your presentation?
Yeah, of course. But the problem, I cannot share my, okay. Okay. Hello to everyone. I'm Kanan, lecturer at University of Human Development at Suleimania, Iraq. My title is Fuzzy Logic-Based Metric for Machine Translation Evaluation. This is our outline. Let us start with the aim of the work. Our aim in this work is to address the challenges in natural language processing generally, specifically for machine translation evaluation metrics. And then we will try to propose a solution. Regarding NLP issues, really there are many different issues. Here we have chosen one of them. We chose BLUE, which stands for Bilingual Evaluation and Study. As a case study, as you know, BLUE is one of the most commonly used metric for evaluating machine output, machine translation output. Here I'm trying to show the problem rising with the blue metric, this commonly used metric. Any majority, if not all, automatic metrics using for evaluating machine output, focusing on syntax, or we can say tokens in overall the sentence of the or the text in general. So blue usually use a simple mathematical equation. It's shown here. It tries to it tries to find the similarity between the candidate and the reference text. So I have given a simple example here. If you have these two candidates, which is text, and the reference is this one, it's the complete sentence. So we got somehow in some cases 100% accuracy, and at the same time it has no meaning at all. So fuzzy logic can be one of the solution, one of the promise. As you know, fuzzy logic can serve to return to the mathematician, a computer scientist, Lutfi Zada. As you know, he proposed this concept in 1965. He introduced a new idea, behind the classical logic that talk about 0 and 1. In fuzzy logic, we have many valued logic between 0 and 1. So why we need fuzzy logic? Actually, there are many, more than two, but I have just focused on two base and reason why we need, why we used to use fuzzy logic. So the first one is the ability of fuzzy logic to deal with human reasoning. I mean, vagueness, uncertainty, and impression. And the second one is its ability to deal with real-world problems. As you know, in real-world problems, not all all the cases we have the sharp or the hard boundaries. As you know, as you see here, in fuzzy logic, we have the membership functions that deal with, the vague boundaries. It means that in fuzzy logic, there is no a sharp can convert or transfer from one region to another region. This is our workflow diagram. We have what we have done. We collected a bunch of text, Turkish from Turkish text, and we translated to English using 3 different machine translation systems. One is Yandex, and one is Google Translation, and we built by our own a new prototype, which is a neural machine translation. So actually, the reason behind the third one, as you know, the Yandex and Google Translation are 2 of the most commonly used engine for translation text. But the third one, we just built it, we created in the sake of, just to show the challenges or the limitation of blue metric. Then we evaluated the output, the machine, the output of all 3 different machines using blue and our fuzzy-based proposed metric, and the third one by manually, or we can say human judgment. We have given this bunch of text translated with the reference to 3 different native annotators. Then we compared all these outputs in order to conclude which one, either the blue or our proposed metric, is a bit closer to human judgment. So we did the same for the Google Translation and the third prototype. These are the steps of the experimental or the practical. So we had used, apart from the Python code, there's a tool in MATLAB which is called the fuzzy logic tool. So, but we have only two inputs. One is called semantic and one is called syntax. And we have only one output, which is the accuracy, or we can say precision. As I mentioned before, majority of the metrics used for evaluating machine translation, they focus on the either semantic, on the syntax only, or or just the similarity between the tokens they found in the text. But we, apart from, in addition to the syntax, we have added the semantic as well. And this is the, as I mentioned before, the membership function for each input and output. For semantic input, we have membership function, which is a Gaussian membership function, and with 4 different values. One is poor, and then we have average, we have good and excellent. As you see here, there is no sharp convert from one region to another. This is the reason behind using the fuzzy logic concept. And the second one, for the second input, which is syntax, we have weak, and we have average, and we have good, and we have used trapezoidal membership function. Then for the last one, which is the output, we have low output, and we have fair and high, and somewhat we can say perfect. The core of fuzzy logic process is the using of the rules. Actually, we have more than these, the 4 shown rules here. We have 2 input. One is, as I said, semantic. The range is from 0 to 10, and the second one is syntax, and the range are the same. So we have different rules. Each input has the impact will be using all different rules. For example, in rule 1, what we have, if semantic is poor or syntax is weak, so then accuracy is low. Or if semantic is good or syntax is good, their accuracy will be high. Then these rules will be we have a summation process after, and it will go for the output. Both inputs, I mean syntax and semantic, have impact on the accuracy on the output, but with different weights. This is the simplified version of the how fuzzy logic architecture. In the real world, all the inputs are crisp. This crisp should be fuzzified. It means should be converted to fuzzy, fuzzy input. Then by using the rules, I have shown it before in the previous slides. So these 2 will be 2 inputs for the interface engine, and the output or interface engine will be, once again, we have the defuzzification of the output, and the output should be in crisp. It means that crisp can be the term opposite to the fuzzy. In the real world, the values are crisp, though the finally should be after the processing, should be returned back to the crisp output. And this is our formula, our fuzzy logic based approach formula is more complex than the formula of blue metric. As you see, we have two input, one is syntax and the second one is semantic. Our approach tries to find the similarity between both the candidate and the reference multiplied by its weight, as I said before. Not both syntax and the semantic in all cases have the same weighting. Then what we have the second parameter, which is semantic. It tries to find the similarity between the candidate, the semantic of the candidate to the semantic of the reference. And finally, we get the accuracy. As a result, after collecting the bunch of text and translated, then we evaluated using three different approaches. One is blue, and one is fuzzy logic, and the third one is human score, or we can say human judgment. For Google Translation and Yandex and our proposed neural machine translation. So as you observe here, in some cases, blue metric gives high score for low quality output, in opposite to our proposed approach. It gives more, reasonable or accurate or closer to the human judgment for all three models. In order to show the limitation of blue metric, we have done another comparison regarding what the types of the responses we get from the machine translation system. As you know, the types can be positive, true positive, or false positive, false negative, and true positive. And we use this simple equation, which is precision, to calculate the accuracy of all systems. As you know, it's about 500 examples of samples of translated text. We got this result. Once again here, our proposed fuzzy logic basic metric outperformed the blue metric for the randomly selected those bunch of text. All the results are shown here. As a conclusion, briefly, you can say that fuzzy logic gives reasonable, sensible answer, specifically to areas that involve, the vagueness or common sense, or some term we can say for pragmatic cases. So by conjoining natural NLP with fuzzy logic, so this can be one of the solution actually to bring quantifiable change to the output of any area on any application related to to natural language processing. And in the future, this concept, fuzzy logic, can be merged with advancements in machine learning to bring more desired output. This is briefly what I have presented the work. And if there is any question.
Kannan,
Yeah.
Good presentation.
Thank you.
With the permission from the chairman, I would like to ask, what is the application of your research?
Yeah, the application of our research will be a metric automatic metric for evaluating machine translation output.
So it is for NLP only, or it can be applied to other areas also?
Yeah, it specifically can be used for evaluating machine output for text translation. Just for yeah.
Achha. Fine. Okay, it's all from my end.
Yeah. Okay.
I just have one quick question. First of all, thank you for the presentation. Very good presentation. And I'm just wondering, what kind of practical applications do you see or do you envision in the future of these results? And will this be somehow available for students, teachers in a university environment, or will it be more publicly available for everyone else?
Yeah, okay. Actually, regarding the evaluating the machine output, I mean the machine translation, still there is a huge gap. There are different many approaches can be used for that, but no approach is perfectly give the accurate answer. So for that reason, in most cases, a part of using these automatic approach or metrics, once again we come back to the human judgment for the manual evaluation. So actually, we got a good result. As I said in my presentation, I compared our result with the one of the best and the most commonly used metric, and our result actually outperformed, the blue metric, but still it needs to be more accurate in order to be to work as a a ready or a complete tool to be used by anyone in educational setting.
Thank you so much for that answer.
Thank you. Thank you.
Thank you. Thank you so much for your presentation. Thank you, sir, for your valuable questions. Now, moving on to the next presentation, I would like to invite Mrinal to present her paper on USD to INR exchange rate prediction, a deep learning approach for forecasting currency exchange rates using different techniques of LSTM. Dear presenter, could you please proceed with your presentation?
Yes, sure. Thank you. Is my screen visible?
Yes, it's visible. You may please proceed.
Yes. So, hello everyone. I am Runal Vibhute from Cummins College of Engineering, currently in the third year of my computer engineering, and I am here to present the paper written by myself and my team, Shreya and Professor Varsha. The title of our paper is USD to INR exchange rate prediction using a deep learning approach for forecasting currency exchange rates using different techniques of LSTM. So this is going to be the agenda for today's presentation. Let's dive into it. The foreign exchange market serves as the backbone of global finance, facilitating trading and exchange of currencies. Accurately predicting exchange rates, such as the USD to INR, is crucial for businesses, investors, and individuals alike. This predictive capability is essential for managing cross-border investments, enabling informed decisions on resource allocation. Additionally, it aids in planning travel budgets, ensuring accurate expense estimates for foreign trips. Furthermore, exchange rate predictions plays a vital role in mitigating financial risks associated with currency fluctuations, safeguarding profitability and stability of business investments. Now that we understand the importance of accurately predicting the exchange rates, so how do we go about this? So the answer is keeping constant track of price changes of USD to INR, and predicting future price requires time series forecasting analysis. So this paper introduces the use of LSTM, long short-term memory, one of the many deep learning techniques used to achieve our target. It remembers past trends and evolving patterns. And LSTM is a particular type of RNN with a mechanism to avoid the vanishing gradient problem and learn long-term dependencies. It is also capable of learning short-term dependencies too, hence the name long short-term memory. In this paper, we have investigated the 3 out of 4 or 5 LSTM techniques known as the vanilla, stacked, and bidirectional LSTM for the time series analysis of currency exchange data. Our objective is to find a robust and accurate model for the future exchange rate applications. Previous studies that focus on methodologies for enhanced prediction accuracy include traditional models like ARIMA, where hidden Markov models, etc. But they struggle with nonlinear relationships. To overcome such limitations, we use LSTM, which can capture temporal dependencies. These are some of the research papers we referred to. Some more techniques people use for this kind of analysis is SVM, that is support vector machine, random forest, and neural networks. The 3 architectures of LSTM that we implemented were vanilla, stacked, and bidirectional LSTM, which have been previously used in many time series forecast models, of which none of were used for currency rate prediction as per our knowledge. All these types make use of 3 gates to process the information and generate a relevant output. The gates are input gate, forget gate, and the output gate. The input gate controls the amount of new information to be stored in the memory cell. The forget gate regulates the amount of information to discard from the memory cell. And the output gate controls the flow of information from the memory cell to the next hidden state and the output layer. Each LSTM model uses these gates. Here's a brief comparison between the 3 types of LSTMs. Vanilla LSTM has a single layer architecture, while bidirectional LSTM has bidirectional connections. Stacked LSTM consists of multiple LSTM layers stacked on top of each other. Vanilla LSTM captures information in a unidirectional, that is forward manner. BLSTM captures information in both forward and backward directions. Stacked LSTM captures information in a unidirectional manner at multiple levels. Vanilla LSTM captures short-term dependencies well. BLSTM captures both short-term and long-term dependencies. Stacked LSTM enhances the learning of dependencies at multiple levels. Vanilla LSTM generally trains faster than BLSTM and stacked LSTM models. BLSTM and stacked LSTM generally tend to have a better prediction performance compared to vanilla LSTM, with BLSTM having a better performance on certain tasks. We began by collecting data of 1 USD price in INR for almost the past 20 years. We trained the dataset and conducted experiments on it by changing the activation functions, number of neurons, and number of epochs, etc., and noted the changes. These are the steps carried out in brief during the experimentation, namely data collection. We collected data from period of January 1991 to June 2023. We removed the outliers in the data pre-processing. We trained the data till December 2023 and tested the data for the next 6 months. We made use of all 3 LSTM architectures and did performance analysis, that is calculated MAE, RMSE, and R-squared error. The results of analysis carried out on the data sets are displayed here. Of these, the bidirectional has the least mean squared error and highest accuracy. This is how the test versus the predicted data graph plotted look like? The predictions are pretty close and accurate for the bidirectional LSTM as observed here. Here our analysis indicates that the bidirectional LSTM outperforms the other LSTM techniques in predicting the currency exchange rates. Its unique ability to incorporate both past and future information simultaneously leads to accurate and closer predictions. Additionally, bidirectional LSTM offers improved resilience to overfitting and a deeper understanding of complex data patterns, making it the preferred choice for currency rate prediction tasks. Thus, embracing the bidirectional LSTM sets the stage for a sharper financial decisions in the ever-evolving global market landscape. These are the references we used for our paper. And thank you. This was all.
Thank you. Thank you so much for your presentation, sir. Any questions?
Yes, we'll move to the Munta, sir.
No questions from my side, but I want to thank you for a great presentation.
Thank you, sir.
Mrinal, good presentation, and that too at undergraduate level. You are saying that you are third-year student. You have done very good job.
Thank you, sir.
Fine, but as far as machine learning models are suggested or given, which will be the better, and does it depends upon application areas?
Sir, can you please ask the question again? I didn't get.
Acha. The first question is that, according to you, which is the better model in machine learning? And second question is that, does the best or good model depends upon the application area?
Yes, sir. Sir, for answering the second question, the different types of models will differ for different applications. For example, if there is a time series model and we use some convolutional, let's say LSTM to it, and it requires different kind of features to it. So if the time series model does not have many features, then that model is not going to be useful for it. And there should be specific models that are relevant to a specific application. So yes, I think that the model type depends. And according to me, deep learning techniques are deep learning techniques are more better in the time series kind of analysis.
Okay, fine, Mrinal. Thank you very much. It is
Thank
all.
you, sir.
It is all from my end.
Thank you, sir.
Thank you, sir. Thank you, Mrinal, for your wonderful presentation. So this brings us to the end of our presentations. So I would like you to have some valuable remarks to all our participants. Could you please proceed with the same, some valuable remarks to all our participants?
So should we start with the Monta or should I start?
I just can say a couple of words. I think to summarize the papers, a lot of these papers are concerning algorithms, and we can see that the AI research has expanded a lot since the introduction of ChatGPT for the past 1.5 years. I think we're probably going to continue with seeing a lot more research into algorithms as the AI field continues to expand in 2024, 2025. So it's very valuable and very interesting to see this research, and I look forward to see more research about this in the future. Thank you so much for your presentations. I think everyone did a great job, and I wish you the very best moving forward.
From my end, should I go ahead, Manta? Yeah.
Yeah.
From my end, thank you for thank you for accepting, or thank you for inviting us a session here. Thank you to especially organizers for calling us and showing the confidence that we can justify to the job. Thank you to Mr. Amit, Dr. Amit. Basically, he is there because of whom we are get connected, and we are involved in that. And most important, thank you to Aarti, Richa, and my co-host Monta sir. This was the first time I am hosting with you, sir. Co-hosting with you. So thank you for being kind, generous, and
It was a pleasure. Thank
understanding.
you yourself.
Yes, yes. As far as research points are concerned, as we have gone through the paper, it can be noticed that most of the times research is not the thing which is very complex and can be presented in a complex way also. At fundamental level, it should start with the application. In many presentations, these things was missing. Rather than many questions from my end also and Montar also were about the application areas of research presentation. So it should start with the fundamental thing to that which are the application area, and eventually it should lead to that how you came to that application area and how you are contributing to that application area. So it will give the good results. And I have seen that the presentations were varying from the application area, from physiologic to the blockchain. So that shows the horizontal space, the way by which the research is going on. So it is good to know that in this extensively research is going on. So that is all from my end. Thank you very much. I will be happy to be connected, associated with if any author or any person from this gathering want to connect with me. I will be happy. You can find me on all social media platform, LinkedIn, Google Scholars, and all these things. You know my name, Shafi Pathan. At the end, I want to thank you, my university also. I am representing MIT EDT University, Pune, because these are the person or these are the people because of whom I can stand in front of you. So thank you to my university, my country, and all my people. So thank you. Wish you all happy researching and have a good day.
Thank you, sir. Thank you, Montathur sir and Shafi sir, for your valuable words. So I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for your support during this 9th version and all the previous 8 versions of the conference. We'll be happy to have you in the 10th version as well. In the 10th version in 2025. All our presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have been forwarded to Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2024. I would like to thank both our session chairs, Professor Shafi Pathan, for chairing the session. Thank you, sir. Thank you for being thank you for your valuable presence.
Yes.
And Professor Montathur Farhan, sir, to being a part of this session chair. Thank you, sir. Thank you for
Thank
your
you for having me.
I would like to request everyone to please switch on your cameras so that we can have a final snapshot of this virtual conference. Thank you. Thank you so much. Have a great day. Thank you. Stay safe. Bye-bye. Take care.
Likewise. Thank you so much. Bye-bye.
Bye-bye.